Sure. Okay. Let's.
Great.
So Aziz, welcome. You had the first presentation, Rising Temperatures, Rising Risks, Ecological Dynamics Across the Arctic.
Yes. So thank you very much for giving me the floor. I will try to show my presentation and you will tell me whether you can see it on the screen or not.
We can.
Is it okay?
Yes.
Thank you. Thank you. So I think we can start. Well, my name is Yulia Zis, and I work at Siberian Federal University. And today I will deliver a speech on the topic rising temperatures, rising risks, ecological dynamics across the Arctic. First of all, I think everyone understands that over the past several decades, the Arctic has experienced significant warming. And today we can we can witness the three main evidence of that. First of all, it is the fact that the permafrost is melting. The second very important thing is that the composition of snow is different. I will actually touch upon this issue a little bit later in my report. And the third factor is that the ice is thinner. I mean the structure of ice. According to the meteorologists of the Royal Netherlands Meteorological Institute, nowadays the Arctic region is warming almost 3 times faster than the global annual average. Actually, it was already mentioned today that twice, but actually this data is fresh. I mean, the year 2020. So this year we received this information that almost 3 times. Nowadays, I think you also know about this phenomenon. In the Arctic region, such kind of a phenomenon takes place as the Arctic amplification. So what is Arctic amplification? So the problem is that in the Arctic, the ice melts and some lighter surfaces, which are snow and ice, are replaced by some darker surfaces, which are water and land. And water and land, these darker surfaces absorb at least 80% of the previously reflected heat, and consequently less sunlight is reflected back into the atmosphere and more is absorbed by these dark waters, and these waters become warmer and warmer, and actually they make more sea ice to melt. So this process is called Arctic amplification, and according to some statistics, about 43% of the summer ice, summer sea ice, has already disappeared in the Arctic region since 1979. And many scientists nowadays are predicting that there will be no summer ice at all in the Arctic by the year 2030. So I think it is a disturbing trend. That is why we should take it into consideration. So answering the question, why is it important to pay particular attention to the problem today? I should say that first of all, we should look at 2 different aspects of this problem. The first aspect is local climate change, I mean the climate change in the Arctic itself, and the second aspect of this problem is global climate change. Well, as for the first aspect, talking about local climate change, it is really important to mention that this local climate change has 2 dimensions nowadays: ecological dimension and human dimension. So as for the ecological dimension, we should first of all say that climate change in the Arctic impacts Arctic ecosystems. What does it mean? The Intergovernmental Panel on Climate Change in 2019 presented a disturbing scenario of a sea level rise, but by 1.1 meter by the year 2100. It is also important that coastal erosion is intensified by thawing permafrost and melting ice, which protect the Arctic coasts from storms. And these permafrost, so there is one more danger, because these permafrost areas contain big amounts of carbon, which is usually released in the form of gas. So this is methane or carbon dioxide. And if the permafrost warms up, it actually releases these gases. And at the same time, it is clear that the release of these greenhouse gases aggravate the situation, aggravates the situation of global warming even further. And in general, we can actually say that the problem is relevant nowadays because the weather in the Arctic is now a kind of an indicator of this disturbing trend, because as we know, the weather in the Arctic is becoming more extreme, with more storms, more rain and snowfall in winter, and more droughts in summer. And climate change in the Arctic has also influenced the biodiversity of various insects, of different animal species, as well as local plant vegetation and the marine environment. And as we know, oceans absorb the majority of the carbon dioxide emissions. And this carbon dissolves in the seawater, producing some carbonic acid. So actually, rising acidity levels rapidly shift the chemistry of the ocean, and it destroys the minerals vital to oceanic shell building creatures. For example, high acidification levels have already caused oyster die-offs in the Pacific Northwest. And actually, it was the first dimension, the ecological dimension of this problem. But this problem also has a human dimension because it influences people. First of all, we should mention indigenous population, in particular the Inuit. As it was mentioned above, ice melting leads to shore erosion, coast erosion from waves and wind. And as a consequence, people's homes and sometimes whole villages are falling into the sea. And that is why nowadays some separate homes or sometimes villages have to be moved. And one more problem is hunting, because as we know, indigenous people, so for indigenous people, hunting is really important. It's vital actually, and hunting now becomes one more problem because the thinner ice, as it was mentioned at the very beginning of my report, makes hunting much more dangerous. The problem is that the ice melts from the bottom, and actually it's very difficult to say whether the ice is safe or not. And that is why more and more people are falling through this ice and get injured or sometimes die. And that is why, so moreover, the melting permafrost is destroying the infrastructure. I mean, the foundations of roads, houses, and other buildings. And actually, it is also a problem. So moving on to the next aspect of the climate problem, of the climate change in the Arctic, we should mention, of course, the global climate change, because according to some experts, today the problem is serious because local climate change, I mean climate change in the Arctic, influences global climate change. And as an example, we of course can give extreme weather conditions elsewhere, all around the world. For example, I think everyone remembers record-breaking winter temperatures in the US, Australia, and Eurasia, or summer temperatures temperature records and wildfire seasons in Alaska, in Siberia, in 2019 and 2020. And that is why, according to some experts, the Arctic has already reached its climate change tipping point. So what is tipping point? Tipping point, it is a point at which further environmental change becomes irreversible and self-reinforcing. So actually, it is a very, very important moment, because now we can say that we have this tipping point only in the Arctic, I mean locally, but still we should tackle the problems because if the problem aggravates even further, it might be really difficult to solve it. That is why the main question now is whether the world community can combine its efforts to tackle the problem of Arctic warming effectively to prevent a global tipping point. And that is why, moving on to the conclusions, I would like to draw a number of conclusions. So first of all, and I think it is really important to emphasize that today Arctic climate change is real and it is a threat. So we should admit it. Secondly, we should understand that neither in the short term nor in the long term we will be able to solve the problem completely. The problem is really serious nowadays, and it is not possible to solve it up to the end. That is why we should be realists, and we should understand that the only one thing we can do now is to mitigate the seriousness of this problem, but it is also important. Thirdly, the Arctic warming can be mitigated by reducing global carbon and methane emissions. And in this context, and I know that it was already mentioned during the first panel, because I presented there as an attendee, in this context, the transition to zero carbon energy sources, for example, solar energy, wind power, and hydropower, is really important. So this can really help. And the fourth and the final conclusion is that Arctic climate change and global climate change are closely interconnected. They are intertwined. And if the problem of rising temperatures in the Arctic is not addressed properly now, in the near future, it can aggravate even further, and it will lead to more severe repercussions. And in particular, it may cause a global tipping point. So thank you very much for your attention. This is everything I wanted to tell you. If you have some questions, I'm glad to answer them.
Thank you so much, Yulia, for your interesting report. Yes, sure. If anyone from the audience has any questions, feel free to drop them into Q&A box. Or maybe panelists would like to ask Yulia their questions. You're free to do so as well. Mm-hmm.
If I can just ask one quick question. Yulia, thanks for the presentation, but I just wonder, so what are the arguments to say that the tipping point in the Arctic is just now, not will be in future, not past, but is just now? So what arguments support this statement?
I see. I see what you mean. So actually, yes, if we discuss the problem of the Arctic tipping point and just the local tipping point and the global tipping point, I actually thought you might ask me something like that, and it is a logical question. It is not my idea. Just I do not say that I'm the author of this idea, but it is Daisy D. I mean, in her article, how Atlantification is making the Arctic Ocean saltier and warmer. This author expressed this idea, and I just took this idea from her, but the article is fresh. I mean, it is a disturbing trend because this article was issued on the 16th of January 2020, so actually a year ago. And according to the information which is given in this article, now the situation is quite serious. I know that in Russia, maybe we do not have this information because it is the Western article, but still, if the problem is emphasized there, I think we should also pay some attention to this problem, and actually we should try to pay some attention. I cannot say whether it is true or false. I just give you the information which I took from one of the Western authors, but I think if they proved their viewpoint, it is important to take it into consideration.
Yulia, if I could follow up, as I mentioned after the first panel, it seems to me that the incentive to stop using oil and natural gas as energy sources is not concentrated in those who profit from those, the extraction of those resources. So it seems to me that if there were a way to estimate another tipping point, and that would be when would there be a tipping point for the use of zero carbon energy sources that would make it basically economically unattractive to continue extracting carbon causing energy sources. Has anybody looked at the problem from that perspective so that we could see, I mean, we're seeing that batteries are improving really quickly, for example, and wind power and solar power now is at a level that it's just getting cheaper and cheaper. The Chinese are getting involved in the development of solar panels, making it yet cheaper again. Is that the kind of tipping point that we might want to look at to see if economics could make a real change in the way people are viewing the use of energy sources?
Mm-hmm. So I see what you mean. So if we compare to different energy sources, of course, in terms of efficiency, oil and gas are nowadays are more efficient, of course, than these alternative energy sources. But still, if we talk about tipping points, of course, we know that in terms of carbon dioxide emissions and actually their harm to atmosphere, they are not that good. And I think, you know, now we are, I mean, the whole world, not only Russia, but the whole world, we are somewhere in a transition process. So we understand, and I mean, sooner or later, people in every country will understand that, well, we should try to move to change the approach to our economic development, and actually we should move from this resource economy to the green economy. And actually some countries nowadays are already doing this. And I mean, even if we now try to use some resource-based economy, it is still possible, but still we should remember that it is not for the long-term perspective. It is something for the near future or maybe for the middle term, but still then we should move on to the green economy if we want to have something which is called sustainable development.
Okay. Answered your question, Joel?
Yeah, sure. Yes, thank you.
Okay, thank you so much, Yulia. Thank you for your report. We're moving on now to the next report titled Soil Emission During the Summer Season in Siberian Boreal Forests, presented by Anastasia Makhnykina from Siberian Federal University in Krasnoyarsk. Anastasia, go ahead.
Thank you. So, I hope you can hear, you can see it, yeah? Do you? Okay. So, your colleague, the participant, and today I would like to tell you about the soil emission during the summer season in our boreal forest in Siberia. And I would like to start from actually carbon balance in the ecosystem, because it's the main important point that we should start from. And actually soil emission and one of the most important part of the carbon balance. It consists of heterotrophic and autotrophic or root respiration. And it's actually CO2 released from the soil. And it's really important part of the balance, and especially for the boreal region, which are very sensitive to the climate change, which was already mentioned here in the panel before. And this is actually a very complex process, soil emission, and this process may be sorry. Okay, this process may influence many factors with different origin. Anthropogenic impact by the clear cutting or logging, by some pollution or burning some fossil fuel, and another external factors, but their natural origin. And today I would like to mention two of them. It's temperature and precipitation. So how about the Russian forests? We have actually a very big area of boreal forest in our country, and that's why it's really big question for us. And actually, one of the recent research, it was observed that the soils, they consist in 4 times more carbon than other phytomass. It's really important because it's a very important source, future source of carbon that we should mention, and we should remember about it. So actually that's why we have a big uncertainties for our model. And another big lack of data for some of our areas in the boreal region as well. And sometimes we use the different methods to take the data, to observe. So, and the research question of our research was, and the estimation of effect of climate variables to soil emission in the middle taiga forest of Central Siberia. And to reach this answer to this question, we made three main steps. The first one, it's a direct measurement of CO2 emission. The second one was analysis of interaction with climate factors. And the third one was modeling or modification of the existing model. So our research region is Luhansk region of our CRI, and it's international research station, which is called Zlotny Tower Observatory. It's a common project with the Max Planck Institute of Vienna, and it's a southern border of Russian Arctic area. So our research was performed in 4 sites. 2 of them was natural sites, natural forest. It's lichen pine forest and the Fidermost pine forest. Also, we had a mixed forest, which was the stage of post-fire succession, and the destroyed area after the tower building. So we performed the direct measurement in the forest. We used the CO2 flux gas analyzer, which is called LICOR, and also we made some temperature and moisture measurements in the forest. So now we have 5 different seasons by the precipitation conditions. It's very important because it's very good factor to analyze the soil emission. So you can see here we have seasons with drought conditions, and we have a season with over precipitated conditions, and we have like with the middle conditions or close to the average. And here also presented two of them, 2012 and 2015, which were we found the most differences by the meteorological conditions. So what actually we observed? So here is presented the forested area, and we found that the highest fluxes we observed in the mixed forest. So it's actually was expected because of higher biodiversity and root biomass in the soil and the plant biomass, I mean the living plant. So lichen pine forest and phyton moss pine forest show us close results, very close results. And for the years with drought conditions, we have a very low emission rate during the whole season. There were no any dynamics during this season. And here is presented our destroyed area. Here is no dynamic at all. Just for the season with over precipitated condition in 2015, yes, we found some dynamics, but it's really low also, unfortunately. So actually the year of this destruction was 2005, and unfortunately 10 years it's not enough to recover some natural conditions for these areas. So here is presenting the whole emission for each season, and it's very similar graph to the graph with the precipitation conditions, if you remember, because the higher emission we observe also in the year with the higher precipitation. So later we analyzed the dependence between the soil emission and soil temperature. And actually we didn't find any good correlation between them, which was actually a surprise for us, because normally it's already known in literature and before that temperature actually control this process. So we decided to look in the moisture. And what we found here, this is the threshold moisture, which is represent the significant correlation between soil emission and soil temperature. At this exact moisture, different forest types. So we took this number and divide by these two groups for each forest type. And what we found a good correlation between the soil temperature and emission for the group with optimal moisture conditions. For all forested areas except our destroyed area. So later we calculate the Q10 coefficient to prove our hypothesis, and found that the sites and the group for each site was drought or where moisture was not enough for emission rate, we have very low temperature sensitivity as well. So then we take the simple exponential model and modify this model by adding our soil moisture, optimal soil condition, which we calculate from the direct measurement. So, for the modeling, we need the continuous data. We took the data from the tower. We took the data for soil moisture and soil temperature. And later we model our data. So what we found, the model, which includes temperature and moisture parameter for summer season, then our measurements very good correlation between them. And a model which includes just the temperature conditions, unfortunately, doesn't show us any dynamic during the summer season. And actually, we cannot use it if we're interested in the seasonal dynamic. So here are some statistical data, which is also prove our model. We put two of them. It's adjusted R square and information criteria IK. I would say it's supported our model, except just a year with a very small amount of measurements, the last one. And here we also compare the different areas for one season by these two models. And we also found that our model, which includes temperature and moisture parameter, works very well for most of them, except the destroyed area, which is actually work the same with the temperature and moisture parameter. Probably it does because of there is no any living part of plant or microorganisms, which is very good correlates with a moisture parameter. So, and here I would like to sum up my talk. So seasonal magnitude of fluxes determined by the plant cover of particular plots and the particular season conditions. So optimal moisture, which was found for each site, presenting the limiting conditions for soil emission during the summer season. So the drought condition, the temperature sensitivity doesn't depend on the soil, on the ecosystem type, and the rate of soil emission goes up. And our new modeling approach provides more precise information about the functioning of this ecosystem during this season, during the summer season. And in the future, we plan to estimate another limiting factor, which is nitrogen for this area. We would like to calibrate our model for another areas. And we would like to estimate our annual functional role of our forests. So if it's sink or source of CO2. Thank you for your attention.
Thank you, Anastasia. Does anyone have questions for Anastasia about her research and report? I have a very simple question, I think. So what are the main reason, the affecting factors for soil emission?
Sorry, I have some problem with the, could you repeat a bit, one more?
So what causes soil emission? What are the reasons?
Okay. Actually, yes, as I mentioned when I started my talk, it's a very complex process. And it's combined by the activity of soil microorganisms, by plants, by the processes of decomposition of the plant in the soil. And this common flux, which is released from the soil.
So external factors, right? Like raising temperatures and maybe some human activity, they do affect it too.
Yes, but unfortunately, we cannot say exactly what will be the effect actually from the high temperature, because it depends from another factor, from another limiting factor, which is moisture or water condition for our region. About the human activities, it's also under discussion, because now, yes, we can see the effect from the logging, from the clear cuts, yes, but it also depends from the season. So it's not so exact
So straightforward. Yeah. I see. Thank you. Any of the panelists have questions? No? Okay, if there are no more questions from the audience as well, we can now move to our next report, and we will have to skip Alexandra Yershova's report because she canceled just now because she can't be present. She was delayed at work and cannot join us, unfortunately. And we also have a cancellation by Inga Banshikova. Her report comes a little bit later. So basically, we move right now to our next, second to next report. Multi-scale Arctic ocean dynamics from high-resolution satellite observations by Igurkaslov from Russian State Hydrometeorological University in St. Petersburg. Okay, go ahead.
Thanks. So I'm just starting to share my screen. Okay, can you see it?
Yes, all good.
Okay. Okay, so I'm just go to the full screen mode. Yeah. So here there are a few talks about the Arctic land and permafrost cover, but now we move a little bit to the Arctic Ocean, and I will shortly speak about some dynamical processes in the upper ocean layer that could be effectively observed from high-resolution satellite observations. And so I represent Russian State Hydromet University and also Marine Hydrophysical Institute of Russian Academy of Sciences. And so first of all, just shortly, objective of this study is to use high-resolution satellite data, and in particular, we don't use all possible satellite data. We mainly use synthetic aperture radar data. It's a special device that is very effective, especially in the Arctic Ocean, because these measurements made by this kind of radar are not dependent on weather conditions and illumination conditions, which means that it can effectively work under severe weather and dark conditions during the winter time. And so we have attempted to use this data of this particular sensor together with felt measurements and model results to better understand properties and hotspots of different dynamic processes in the ocean. And so here briefly on the left side, you can see this is a illustration of Envisat ASAR instrument, and on the right, Sentinel-1. So the first one was working during 10-year period some time ago, and Sentinel-1 still works. It was launched in 2014. And in general, one may ask why use satellite data? And it is obvious that for the Arctic Ocean, which is remote and having severe weather conditions, remote sensing, particularly with satellites, give us very nice opportunity to observe very large pieces of ocean and get information about the processes there, which is not possible by simply going in the field with icebreakers or just by using modeling, because the last one, modeling, needs confirmation and felt measurements naturally cannot cover the entire ocean. So that is why we use satellite data here. And today I will talk basically about two processes. The first one is called internal waves. This process is similar to standard waves we do observe on sea surface, but these waves, they are generated and appear in the ocean interior. at some depths, say at 20 to 50 meter, sometimes at 100 meter depths. And these waves are usually generated by different dynamic processes, especially by tidal currents. So when tidal current is passing some rough topography, bottom topography, it may cause some oscillations of water masses, like shown here. As you see, these very pronounced oscillations, or simply waves, that actually exist in the interior and may have heights, you can just imagine, of tens or even hundreds of meters. So it's like skyscraper high waves that may eventually propagate into the ocean interior. And when these waves break, they actually can cause very different things, like put nutrients up and down, or move them horizontally, as well as mechanically mix water masses in the ocean interior. And what is important, particularly in the Arctic, they may eventually transfer heat from below to the sea ice and then stimulate sea ice melting. And we are lucky that this process is well observed in satellite data. And here on the right, you may see a picture. This is a satellite image, and you may see these alternating bright and dark stripes, which are exactly surface manifestations of these internal waves. And the second process we are observing using satellite data are eddies, or vortices. So on the left, you may see again some examples how they look like. So they could appear differently depending on wind conditions, but usually we have such swirls on a sea surface, in fact, representing real eddies that are rotating in the ocean interior as well. But we can observe such features not only in the open ocean, but also in the regions covered by sea ice. And here's an example of so-called marginal ice zone, where the ice is already mobile and not very consolidated. So this ice movement is also quite often showing us such very nice vertical structures moving either clockwise or anti-clockwise. These features, this process also may strongly impact redistribution of different pollutants, microplastics, and again, nutrients in horizontal as well as in vertical, so that it's important to study where these processes take place, how large they are, how they are intensive in terms of the motions, etc. So here, what we do, we just use satellite data to investigate this process. And the first one the first part of the talk is related to internal wave observations in the Arctic. So here is such a typical example of internal wave manifestation in satellite image. And you can see that in this image, we have plenty of these, again, bright and dark stripes that probably are generated at one particular point and then radiate to different directions, and they may propagate for several hundred kilometers in the ocean. Afterward, they actually eventually break, and when they break at these locations, water masses may experience very strong mixing. And so we have then the analysis of data in 2007, which is shown here. So here you see the map of the Eurasian Arctic Ocean. And these red curves are, in fact, a simplified representation of internal wave locations. So you may see that there are plenty of locations where these waves exist quasi-permanently. And these are not only some shelf regions where the water is not very deep, but also some very deep regions where the water depth is beyond 2000 meter. And so then we have added some observations from recent years, from 2018, And we can observe that, in fact, the internal wave activity regions expanded strongly, and again suggesting that the internal wave regime is changing, and perhaps we are observing more intensive internal wave generation. But then the natural question arises, how big are these waves? What are their amplitudes? Because the intensity of the waves is mainly governed by their amplitudes. And then it was a joint work together with our Norwegian colleagues, which was done north of Svalbard archipelago in July 2018. And here on the left, here are some pink points showing the locations of felt measurements. And this location was specially studied because we have observed a lot of waves in this area before. So the cruise was equipped with quite advanced measurement instruments like autonomous gliders, microstructure profilers, and standard ADCP CTD measurements. So it was interesting that during the measurement time, here is an example on the right, made by ship-mounted echo sounder. You may see that we have registered quite high, 20-meter high internal wave passing through the measurement site. And a bit later on the same day, it was another very energetic event. It was a passage of a huge internal wave packet consisting of several very non-linear and high amplitude waves up to 50-meter high. And during this period, other measurements have shown that, in fact, the entire water column was pretty much mixed because these waves, while they propagated, they started to break. And this caused mixing in the entire water column from the surface till 300-meter depths, again suggesting that they play a crucial role in water mixing and in stimulating heat transfer both downward and upward toward sea ice surface. And so this is a snapshot of satellite observations of these waves. You may see these red curves, again representing internal waves mapped over this measurement site. And basically, we may see that there are plenty of these waves occurring, existing here all around this region and over different other Arctic regions. And of course, they play a very important role in terms of water mixing and their impact on sea ice. And another part of my presentation is related to observing ocean eddies, and these results come from quite recent paper in Journal of Geophysical Research, where we do observe eddies in the Western Arctic Ocean. So we had performed an analysis of quite big data set of about 600 SAR images. And on this map, you can see all the locations where eddies, rotating features, were identified in the Chukchi Sea, in the Beaufort Sea, and over deeper regions over the Chukchi Plateau. And so we can clearly see the locations where these eddies are generated, again, quasi-permanently. And if we then quickly compare the results with high-resolution model shown in the bottom right position, you may see that, in fact, the model prediction quite well confirms to the observations, so that our observations, in fact, confirm the model results. And this is an important step because we have plenty of models working nowadays, but important thing is to validate the model results. And so our satellite observations provide this verification basis to assess the model skills. And so by having this satellite data in hands, it's quite easy to calculate probability of eddies, or simply the frequency, how often and where these waves, these eddies could be detected. And this tells much where we can, again, assume very high impact, high role of these eddies on the hydrological structure, hydrological regime of this ocean part. And what we have observed actually is, so altogether it was about 4,000 eddies identified in satellite data. And if you look then to interannual variability, we can see that in fact we do observe enhanced eddy generation, enhanced higher eddy numbers during recent years as compared to the years of 2007 and 11, which is again suggesting that some eddy activity could be enhanced during recent years due to ongoing changes in the Arctic Ocean hydrology. And the last example comes from a recent opportunity not only to understand where eddies are generated and understand their sizes, horizontal sizes, but also to calculate their dynamical features. And this comes from the opportunity to have sequential satellite data when we have satellite images made with very short time interval, and when they overlap one on each other, we may have areas with larger amount of measurements. And so here on the right panel, you may see a zoom area with quite big anticyclone whose diameter is about 100 kilometers. It's really huge. And by simply tracing ice fields during time period between two images, we can then calculate horizontal velocity field. And it is seen here that in fact this eddy rotates quite quickly. Maximum rotational speeds are about 60-80 centimeters per second, which is quite high for the Arctic Ocean and for the ocean in general. So this data in fact provide very new opportunity, not only again to understand and to reveal hotspots of eddy generation, but also to importantly measure the kinematic properties like orbital velocity and translation velocities, which is again not possible to do with field observations from icebreakers or just by using models, because marginal ice zone representation is a big trouble for state-of-the-art models nowadays. So, and then just to conclude on the results obtained, first of all, we should say that high-resolution satellite data, in particular synthetic aperture radar observations, are indeed very effective to observe hotspots of eddy and internal wave generation in the Arctic. And we may effectively obtain key spatial and kinematic properties of these processes, as well as to understand what is the seasonal and interannual variability of their parameters. What we do observe from recent years is indeed an enhanced activity of these processes, which is perhaps related to the changes Arctic Ocean is experiencing nowadays. For example, that already mentioned Atlantification of the Arctic Ocean, when a higher role of warm Atlantic water is now playing in the Arctic, which potentially results in sea ice melting, more effective sea ice melting nowadays. And we have shown also in our work that these phenomena we do investigate, they have quite broad range of spatial horizontal scales, from very small tiny features up to several hundred kilometers, which again is challenging to observe in situ or model. And finally, we also can get from satellite data the information about the vertical scales and about their energy. And we see that some of these features are indeed very energetic and strongly affect transport of nutrients, again, microplastics and other pollutants, as well as a for sure may impact the mixing and hydrological and ice regimes of the Arctic Ocean. So thank you for your attention. Yeah, and I just wanted to mention that this work, part of this work was also supported by Fulbright Visiting Scholar Program, which allowed us to make close relations with our US colleagues to proceed with these nice results and publish them. Thank you.
Thank you so much, Igor. We have one question for you in the Q&A box.
Great.
So, do you identify internal waves and eddies visually or in an automated way in the SAR images?
Yeah, that's a great, good question. So in our analysis, we mainly used visual identification when a specially trained expert was identifying these features. And of course, this is it's a huge and a bit boring work, but it's quite important. But nowadays, machine learning is so widely used to try to solve similar tasks. But I must say that when you are working with radar images that we use in our analysis, it's actually not always easy to make a good automated method to detect such features. And I haven't seen up to date any good papers saying that this could be easily automated, but I believe that it will be done in the near future.
Mm-hmm. Thank you. We have another question, which I think you partly answered in your presentation. What are the climate change implications of these enhanced eddy activities that you measured in your research?
Okay, so if we are talking about eddies, both about eddies and internal waves, so since these features are quite energetic, then we may, so if talking about internal waves, for example, the more waves are generated, the more mixing can occur, and more effectively the heat stored in the intermediate Arctic Ocean layer may eventually come and melt sea ice, though it will be like a positive feedback mechanism, so that more waves are generated because hydrology is changing, and then again more sea ice is melted, and then again this leads to enhanced generation of waves, for example. But when talking about eddies, it's a bit different story, but also eddies play a very important dynamical role. And so if we would assume that eddy regime is enhancing, then again it will be more enhanced vertical and horizontal transport of different features like heat, momentum, and again this might have a positive feedback on the entire physical system and as a consequence ecological system of the Arctic Ocean as well.
Okay.
But maybe the last word on this would be why this is important to observe such features. So we want to observe to better predict. If we can predict on a good level, then we can predict future changes. So
sure. Okay, thank you once again, Igor. Thank you for your questions, attendees. So I think right now, yes, please, you can turn up your picture. Yeah. Great. So, and yeah, well, we can now move on to our next and closing report of today. Review of the recent changes in the Arctic and their impact on mid-latitudes by Kabir Rasuli from University of British Columbia in Canada. Thank you for joining us a bit earlier today, once again. And yes, go ahead, you can turn on your mic. Okay,
can
great.
You hear me?
Yes. Yeah, we can see
my presentation.
Yep.
Good evening, everyone. Thanks for coming to this meeting. I would like to talk a little bit about the recent changes with different perspective. This work is basically a part of a larger group. Myself and Michelle Fernandez was leading this, and if I can Yeah. So I would like to acknowledge my other contributors, which were basically 30 or so early career scientists from Russia, from India, from mostly India, and Canada and Australia, China. So there was a winter school in 2018, and we were together, and we had a we decided to write a review paper on the recent changes in the Arctic. So this presentation, I'm not expert in that all perspectives of the changes in Arctic, but I will try my best to answer if there is any questions. So I would like to acknowledge funding from Norwegian Nansen Environmental and Remote Sensing Center, also Indian Center for Polar and Ocean Research. So this was back in 2018 in Goa that we had a winter school on Arctic changes. So starting with Arctic, so you know that Arctic is surrounded by 6 countries, and you can see that these are basically the maps showing what areas, what regions are claimed by surrounding countries like Canada, U.S. here, and Russian border, and Iceland, Greenland, and as well as Norway. So with the changes that happens in Arctic, so it will be more activities in terms of shipping and tourism or other developments in the Arctic, which is quite expected in the next not very long. So talking about the changes in sea ice extent. So here I'm showing what is the rate of changes per decade. So the red one is the most strongest change, which is basically sea ice extent in September. So you can see that 11% decrease in every decade in sea ice in September, and March is less than that, is roughly around 2.6%, and in average annual decrease is 4.6% change. So it is a dramatic change in the sea ice extent in million square kilometers. So if we look at the monthly sea ice decrease, you can see that here, for example, this is average changes in 1979 to 2006, the gray one, and these are the most recent one. You can see that black one is 2019, which is almost the record, except for 1 month or a few days in 2016, which was smaller than anything is. We have not updated yet for 2020, but you can see the pattern that how dramatically is changing, especially in September. So that's a very important change. So what is the projections for the future? So you can see here, this is under RCP 4.5 climate change scenario. You can see that we are here almost 5.5 million square kilometer in 2020, and it is expected to decrease almost to 2 or 1/3 of whatever we have right now in terms of ice extent by 2100. So if we look at more pessimistic climate scenario, which is mostly like business as usual, you can see that it will be even more than that. The drop will be even below that 1 million square kilometers by the end of century. So again, this one is for September month, the months that we expect the drastic change in sea ice extent. Why this is happening? Maybe there are so many reasons, but the most important one is black carbon. So black carbon is generated by incomplete combustion of hydrocarbons, and it can come from fossil fuels or biomass burning, wildfires, which is nowadays very frequent everywhere, in Russia, in Canada, in US. So those are source of black carbons that increased in the atmosphere. So it affects all aspects of our planet. I start with atmosphere here. So it changes cloud formation, cloudiness, radiation, and it causes global warming, haze formation, and it affects biosphere. So it can cause some health issues and household air pollutions. It can affect cryosphere, our Arctic or cryosphere is shrinking, not just in the Arctic or in the poles, but also in Himalayas, which we call it three pole or third pole, and thermal cycle is changing. Climate variations are changing due to the black carbon increase. Glaciers retreating, and hydrosphere, water supplies are getting very uncertain. Our land runoff is changing, and water cycle, is disturbed. So here is a very simple schematic view what black carbon does when we have here snow without black carbon versus when we have aerosols, snow with black carbon or aerosols. You can see that here we have more reflectance of the solar radiations versus here we have more absorbed radiations here, which means that snow is melting and temperature is rising and everything is shrinking in terms of snowpack, and if it is ice steps or ice extent. So maybe another reason is Arctic amplification. What is Arctic amplification is that we have kind of double warming. So when you can see here, if we know that Arctic is warming, and we know that it is warming with higher rates than other areas. So warming causing more ice melt, which itself decreases the albedo reflectance. So basically it means more energy absorption. And once we have more energy absorption, we have more heat, and more heat which means that more higher temperatures, and the circle is continued to get to the new equilibrium. So we can see that how it is related to each other. So what does it mean in terms of feedbacks between sea and ocean? So not just sea and ocean, also land. So starting from here, sea ice. If we lose sea ice, we have direct interactions between atmosphere and ocean, and now we have more activities for marine phytoplanktons, and we know that land flows toward Arctic Ocean is increasing, both in Russian rivers and Canadian rivers. It is well established that land runoffs toward the Arctic Ocean is increasing, which means that it brings more sediments to the Arctic Ocean and more minerals to to the Arctic oceans, which is feeding phytoplanktons. So these are the changes that happening both in sea ice and sea itself, as well as land runoff. One important thing that happens is the thinning of ice layers in Arctic. And I think one of the key areas is that this snow on ice properties are changing, because with warmer conditions, there is a chance that we get more rain instead of snow on ice, which may cause thinning the ice. And you can see that, the surface of the ice is not uniform. It has topography, and it is crucial when we have, for example, here at higher elevations, or at some roughness here. You can see that snow accumulation is totally different than when we have less rough areas. So I mean, it is not uniform, it is not heterogeneous. So this causes, more interactions between radiations and snow, and as a result, melt or forming of kind of ponds over the ice, which leading to thinning the ice. And maybe that's one of the reasons that nowadays we have a 1 year ice rather than multiple year ice in this area. So some possible maybe advantage that this might have is opening shipping routes by 2020. So you can see that there is possibility here to have northwest passage here through Canadian North, and through North Pole, and as well as through Northern Sea routes. So this is quite possible to have Arctic shipping routes by 2020 under the changes that expected, and it is happening every year. So other thing that we found interesting, I just list here. One is that natural variability is also important. Natural variability of atmospheric circulations and also oceanic circulations are key to contribute to Arctic warming. And melting Arctic sea ice affects atmospheric and oceanic circulations. These circulations are basically bridging the tropical to polar climates. So any changes to these circulations basically means that changes in tropical global climate systems. And as the previous speaker was talking about the satellite remote, we also see that there is very it is very important to have more and reliable remote sensing data and manned aerial vehicles in combination with the in situ measurements to better understand snow processes, snow redistribution on ice. And sea ice loss in Arctic decreases the surface temperature gradient from equator to pole. So now this gradient or temperature difference between equators and Arctic is decreasing. So it may affect jet stream, and as a result, local or regional climate might be affected. The other thing is that normally we have clouds in autumn and winter, which is kind of functioning as an insulation. And with warming, we expect more cloudiness And basically, it means that more installations of long wave radiation, and again, more ice melt expected in autumn and winter. And wave ice interactions is also important for Arctic sea ice dynamics. And also it is, of course, important for navigations. And so as a result, so this wave ice interactions is not was not incorporated in climate models, but forecast models. So we think that they should be incorporated in climate models. And at the end, also with warming and more activities for migratory birds, there is a quite uh, large literature body that's showing that warming supports bacteria transport to Arctic, and now we are getting more antibiotic resistant genes in Arctic. And also we came up with 4 recommendations to go forward. One is, in enhancing early career scientist perspectives on global research efforts. And nowadays, maybe we have some early career fellowships in the Arctic Council. So we believe that we need stronger early career presence in global community, research community. And also we believe that long-term monitoring and research-based adaptive policy making is a key. And also still we are missing gaps. These gaps are not filled or even not identified, gaps between scientific community and policy. And we need to identify those gaps and barriers and opportunities. And also we need to pay attention to adaptive sustainable developments and local involvements in our activities in the Arctic. So by that, I will stop here, and if there is any questions, I'm more than happy to answer if I can.
Thank you so much, Kabir, for your presentation. Yes, if there are any questions from the panelists or from the audience, feel free to ask them. You could even join us in the discussion if you want to. I mean, ask the question yourself, just send me a message and I could add you to the panel if that's what you want to do. Any panelists, any questions from you?
I just wanted to, you had a reference to an adaptive sustainable development responses and local involvement. Can you give any examples of those?
So I think, mostly, scientists are interested in science questions, and nowadays more travels happening into the Arctic, but maybe the local people perspective is different, so I think and it should be mutual work there, and we need involve early career or scientists from their own communities, or if there is a development there, we need to use their forces, their resources. I mean, and more involvement. They should think that they are involved, and it is not just extraction of resources and disappearance and living behind the pollutants and other issues there.
If I could ask a follow-on question, I believe you referred to a third pole. What did you mean by that?
Yeah, nowadays we call Himalayas third pole. So it is basically because it is highly important, and it is also a link to other poles. There is a recent Nature paper showing that changes in the Arctic, changes in the third pole or Himalayas as well, in terms of transforming aerosols to Himalayas, which is causing issues there in terms of glacier to retreat or snow changes in that area.
That's interesting. I know that along, on either side of the Himalayas, I think you have the world's largest concentrations of population.
Definitely.
And so if you have global warming, presumably glacier melt and runoff from the Himalayas are going to have an incredibly huge effect on those populations.
Definitely, yes.
Are you seeing any sign of adaptation among those populations regarding the way they conduct agriculture, trade, or any of the things that are vital for sustainable economies?
Yes, that development, what I'm suggesting here as a sustainable development is valid in that area as well. Especially, it is highly dense populated area. I think 1.5 billion people are depending on water comes from Himalayas, maybe more than that. So it is highly important, and it is day-to-day issue in that area in terms of development. And I think there are some activities in terms of sustainable development over there, but I think it may take some time, like in the Arctic. So there are more very similar conditions in the Arctic and over there, except for that population is higher than, so those people that living in highlands are affecting more over there.
And we have a question in the Q&A box, which probably also comes as a follow-up of sorts. Will ice melting help solve water crisis in some regions?
I don't think so. Maybe it is temporary, temporary solution, temporary increase in water level, but over long term, it is an issue. I've seen here in Canadian glaciers that we see some increases in stream flows. Yes, for now, but after 10 years or so, I'm not sure. Definitely, it will be lower than that. And this it has been seen in the U.S. and California. Those glaciers that have been disappeared. First they generated high flows, but over the years, that disappears.
But even so, wouldn't these increases in water flows be unpredictable and just as likely to cause flooding as anything that could be used to improve agriculture?
Yeah, I think so. You're right, and it is just maybe couple of months in a spring, and maybe it is not useful for agriculture because it is in the spring, and when they need water in summer, we don't have water. So annual variations also will be high, and maybe not efficient unless you have reservoirs to manage the water. But other than that, it will be more floods, and even though contribution of glaciers are not really high, but it can be high when we have say more melt or more warmer conditions.
Okay, thank you so much. There are no more questions, I believe, from the audience. Thank you once again, Kabir, for your presentation. If I could ask you to stop sharing your screen and just show up together with other panelists. So I could, yeah, that's perfect. So I could take a screenshot of all of you. So can you please look at me? And that's 1, 2, 3, and perfect. Thank you. Great, yeah. So if you have any more questions about your topics, your works, your research, feel free to discuss them. If you don't, we could probably wrap up at this point. If no one has anything to add to the discussion, no?
Let me just ask one tiny question.
Yeah.
So actually two. So well, I have the first question to Igurkaslov. So Igor, in your report, you have mentioned some ideas about internal waves. And in particular, you said that their main role is to mix water, yes, in the ocean. So I also heard that some experts believe that they can contribute to shore erosion. I mean, the process of shore erosion does not occur because of thawing permafrost and melting ice, according to these experts, but just because of some internal waves. So is it true?
Yeah, so there are papers that exactly showing by high quality measurements that in different parts of world ocean, not particularly Arctic Ocean, these waves are causing sediment transport and may affect coastal erosion as well, because quite often these waves are basically propagating either toward the coast or toward the deep water. So, and in 50% of situations, those waves that go toward the coast, they eventually may break just near the coast and cause sediment transport out of the beaches, out of these coastal regions toward deeper water. So yes, it could be also the case for the Arctic coastal regions as well. But I guess it's really actually, when planning new Arctic expeditions, it would be a good idea to try to make such kind of measurements to trace particular wave trends and then to estimate such effects as well. So thanks for the question. It's really good thing. Already partly solved for the world ocean, but I haven't seen that this was done in the Arctic yet.
Thanks a lot. Yes, it was interesting because there are different viewpoints. Yes, and now you clarified things. So thanks a lot. Thank you.
Yeah, thank you.
Okay.
So maybe one more question. May I ask Kabir? So Kabir, what do you think? So you mentioned that nowadays, so you actually showed us some conclusions after your report and made some recommendations. And I just wanted to hear your opinion on what do you think about future prospects of Arctic cooperation? I mean, in the Arctic, as we all know, there are some Arctic states, so-called Arctic states, so traditional actors in this part of the world. But what do you think about some states which are not Arctic, but they also try to cooperate, they also try to implement some projects in the Arctic? I mean, some states from the Asian Pacific region, from some other parts of the world. What do you think about this type of international cooperation?
I think, as far as I know, there are quite large number of countries that are involved. I know for sure Poland and India, and maybe there are others as well. So I think I'm not sure how many countries are in the Arctic Council, but I assume that in future these collaborations will be even more stronger. I think the more closer to get 2020 in 2050, I think there's interactions and collaborations also, or maybe competitions also will be stronger. But what we what we see that, there is a gap between, scientists and policymakers. And in this winter schools that we attended, it was more or less like to kind of identify these barriers. So I think there are some activities are going on, and I think it will be more realistic and more meaningful collaborations among the countries, not just those countries surrounded around the Arctic, but also other countries also will be contributing more to the collaborations there.
I see. I see. Thank you. So you're sure that it's necessary to expand cooperation, yes?
Sorry, say again?
So you're sure that it's necessary to expand cooperation, yes?
Yeah, definitely. Yes, yes.
I see. I see. Thanks a lot. Oh, I have no more
Okay.
questions.
Thanks for the question.
Yeah, seems so. Okay, so if there are no more questions, I think all that's left for us to do is to thank you all for taking part in today's panel. It was the first part of the climate change panel. The second will be tomorrow, so if you can join, feel free. You should have the link to join us at ND. We'll be glad to see you and to hear your questions to other panelists, or you can join earlier for the social panel that we have before that. And good luck you all. I hope we stay in touch, and also do feel free to follow what the Fulbright Arctic Initiative is doing, right, Joel?
Absolutely.
Yeah.
Let's know about the Fulbright program. We were always looking for good applicants, many of whom participated in today's event. But tell everyone about this program because it's alive and well, and we need, as you said, Kabir, we need more young scientists involved in these efforts. And one way to do it is to have people earn master's degrees or do research while being part of the Fulbright program. Thank you.
Okay, then, thank you all. And bye-bye. See you sometime.
Thank you. Have a good night.
Thank you. Thanks a lot for organization.
Bye-bye.
Bye-bye.
Bye.
Thank you. Our
Goodbye.
pleasure. Bye.
Goodbye.